Hello, dear friends. Imagine yourself standing in the middle of a desert at night, the sky above ablaze with millions of stars. Perhaps you've looked up and wondered, what lies behind that light? And in those completely dark places, is something hidden there? The universe is always a vast canvas filled with countless shades. Some regions shine brilliantly, where stars are born, magnificent nebulas blaze, and galaxies spin in cosmic dance. But then there are the dark zones, where light cannot escape, where everything seems to vanish without a trace. That is the place where imagination, courage, and human knowledge are all put to the test. The black hole. We know many things about the universe, but when it comes to black holes, even the most brilliant minds must humbly admit, this is one of the greatest mysteries humanity has ever faced. So, what would happen if we entered one? If one day you were aboard a spacecraft heading straight into the heart of a black hole, what would you see? What would you feel? Could you ever return? The journey you're about to take isn't just an adventure among the stars. This is a deep exploration of knowledge, where science, philosophy, and imagination converge. Hold on to your curiosity, because we are about to enter a place from which no light has ever returned. Black holes, the universe's mysterious gateway. We live in a vast universe, home to billions of galaxies, each containing hundreds of billions of stars. Through exploration, humankind has gradually understood the life cycle of stars, from their birth to their dramatic deaths in supernova explosions. We have learned about neutron stars, massive stellar remnants spinning rapidly with immense magnetic fields. We also understand that the universe is expanding, that light has a speed limit, and that time can be warped by gravity. But all of that knowledge begins to falter when we talk about black holes. Unlike any other celestial body, a black hole emits no light. They are completely dark in both the literal and figurative sense. We cannot see black holes directly. We can only infer their presence through gravitational effects on surrounding objects. A black hole is the ultimate frontier of knowledge, where Newton's laws and even Einstein's theory of relativity begin to break down. So, what is a black hole? Imagine an object so massive that in order to escape its gravitational pull, you would need to travel faster than the speed of light. But since light is the fastest thing in the universe, nothing can escape, not even light itself. The result? A completely dark celestial object, invisible to the naked eye. A dead zone of the universe. That is a black hole. But the fearsome nature of a black hole doesn't stop at its ability to consume everything. Inside a black hole, time and space are no longer separate. They mix together. The meanings of inside and outside become blurred. A black hole doesn't just bend space. It tears apart the very fabric of space-time. And that raises the question humanity has long pondered. What lies inside a black hole? Imagine you are the first explorer to cross the final threshold of the universe. Forget Apollo missions. Forget satellites in orbit. Step aboard a spacecraft of imagination, a vessel powered by intellect and curiosity, and prepare for this grand journey. But before we depart, let's understand more about what we are about to face. Types of black holes, the ecosystem of darkness. Black holes are not a single concept. In fact, they exist in many types, each with its own physical characteristics, from size and mass to how they interact with their surroundings. Classifying black holes helps us understand their origins and the related physical phenomena. In this section, we'll explore the main types of black holes identified by scientists and dive into specific examples near Earth to shed light on this dark world. 1. Stellar mass black holes. These are the most common type of black holes in the universe. They form from the death of massive stars, at least 20 times the mass of our Sun. When these stars exhaust their fuel, they no longer have enough pressure to counter their immense gravitational force, causing the core to collapse. The result is a violent supernova explosion, and the collapsed core continues to shrink until it becomes a black hole. Stellar mass black holes range from a few to several dozen times the mass of the Sun. They can exist alone or in binary star systems. If a black hole draws matter from a companion star, it may emit X-rays, helping astronomers detect its presence even though the black hole itself remains unseen. A prime example is V616 Monocerotis, also known as AO62000, the closest known black hole to Earth, about 3,000 light-years away in the constellation Monoceros. It has a mass approximately 6.6 times that of the Sun and orbits a companion star with only half the Sun's mass. This pair forms a binary system that completes an orbit every 7.75 hours. While the black hole is invisible, anomalies in the motion and brightness of the companion star revealed its existence. 2. Intermediate mass black holes. This type remains mysterious, with masses ranging from a few hundred to tens of thousands of times the Sun's mass. Because they emit no light and are usually found in globular clusters or regions with little astronomical activity, detecting them is extremely difficult. However, growing evidence suggests they do exist. They may be the missing link in the evolution from stellar black holes to supermassive ones. One theory proposes that intermediate black holes form as smaller black holes merge over time. 3. Supermassive black holes. These giants reside at the centers of galaxies, including our Milky Way. Supermassive black holes weigh millions to billions of times more than the Sun. They play a central role in structuring and influencing the motion of entire galaxies around them. A classic example is Sagittarius A*, the supermassive black hole at the heart of the Milky Way, with a mass of about 4 million suns. Though invisible, scientists have measured the movement of nearby stars to confirm its presence. Interestingly, despite their massive size, their outer boundaries aren't dangerous as long as you're far enough. In fact, Earth continues to orbit the galactic center in a stable path, not falling into Sagittarius A* due to the vast distance and proper orbital velocity. 4. Primordial black holes. These are hypothetical black holes thought to have formed during the earliest moments of the universe, right after the Big Bang. They could be extremely small in size but incredibly dense. Some theories suggest that primordial black holes might make up a portion of dark matter, the invisible substance that accounts for most of the universe's mass. Currently, there is no direct evidence confirming their existence, but research is ongoing. 5. Rotating and charged black holes. According to different solutions to Einstein's equations, black holes can possess properties such as rotation and electric charge. A black hole that neither rotates nor has charge is called a Schwarzschild black hole. A rotating one is called a Kerr black hole. If it also carries an electric charge, it is known as a Kerr-Newman black hole. Rotation and charge make the surrounding space-time structure more complex, leading to phenomena like the ergosphere, a region where no object can remain stationary, approaching the dark zone, touching the event horizon. Imagine you're sitting aboard an imaginary spacecraft equipped with the most advanced technology humans could ever conceive. Your sole mission, to approach a real black hole. Ahead of you lies a massive dark region that seems to swallow all light from the stars behind it. But black holes are not completely invisible. As matter falls in, it accelerates to such extreme levels that it emits powerful X-rays and gamma rays. Streams of matter form a blazing accretion disk around the black hole's mouth, like a glowing ring around a swirling cosmic vortex. The closer you get, the more warped space-time becomes. Light from stars bends, a phenomenon called gravitational lensing, causing you to see the same star in multiple places at once. Everything begins to feel surreal. You are now in the boundary between reality and the beyond. As you approach even closer, time itself appears to slow down. Not just metaphorically, this is a real effect, gravitational time dilation. From the viewpoint of an outside observer, You appear to move slower and slower as you near the event horizon. But to you, inside the spacecraft, time feels normal. The moment of contact with the event horizon draws near. This is the point of no return, an invisible boundary where the escape velocity exceeds the speed of light. Nothing can overcome it. No information can escape from beyond it. Once you cross it, there's no going back. Falling into a black hole, a journey with no return. You have crossed the event horizon. From that point on, every direction leads to the same destination, the singularity. In normal space, you can choose to move forward, backward, left, or right. But inside the event horizon, all paths converge to a single point, like all lines of longitude meeting at the North Pole. This isn't just a metaphor, it's a mathematical consequence of space-time geometry. Gravity intensifies dramatically. Your spacecraft begins to shake violently. The gravitational pull on the front is far stronger than on the back. This results in what scientists call spaghettification. Your body stretches into long, thin strands like spaghetti. Cells separate, atoms break apart. Even subatomic particles cannot escape the pull. Yet bizarrely, the entire process happens so quickly that you feel nothing. It takes less than a second. No pain, no resistance, just the universe executing its natural process. The singularity, where time dies. You have fallen into what physics calls the singularity, a single point where the density of matter approaches infinity and all known laws of physics break down. Space-time collapses into a point. The concepts of length, width, and depth no longer exist. Time, past, present, and future, implodes into one. You no longer know if you're moving or still. No light, no sound, no direction. Everything is an undefined blur. You might think of the singularity as a place, but it's more like an inevitable future. Every orbit, every particle that falls into the black hole ends up there. Here, time does not flow, it ends. Or it becomes so distorted that the differences between moments become meaningless. The singularity is where the universe hides its deepest secrets, a cosmic vault that no one can open, and no one knows what's inside. Nothing comes back, the whisper of the cosmos. The universe has a way of reminding us that no matter how far science advances, there are sacred, forbidden zones. Places where light cannot reach, where every question has no answer. A black hole is one such place. You, the imaginary traveler, have reached the very edge of space-time. And standing before the singularity, you realize one truth: everything is over. There is no return path. No signal will ever reach Earth again. Not a single photon will carry your final image. You vanish, completely, as if you never existed. A black hole doesn't kill you. It erases you from every concept we have of existence. What remains are only cold physical consequences. Your mass adds to the black hole's total mass. Your angular momentum becomes part of its spin. Everything you ever were is reduced to 3 basic numbers: mass, electric charge, and spin. No name, no memory, no identity. And yet, in that place, the black hole whispers something profound to us: that the universe still holds unsolved mysteries, and that humans, however small, never stop dreaming of touching them. In the end, the important question isn't whether you can survive falling into a black hole. It's that you imagined it. And in that very act of imagining, we discover the most beautiful thing of all. Curiosity has no event horizon. If you found this journey through black holes fascinating and thought-provoking, consider subscribing to the channel so you don't miss future scientific adventures. Each time you hit subscribe, we take another step together toward the greatest mysteries of the universe. And don't forget to leave a comment below. What are your thoughts on black holes after watching? What part impressed you the most? What topic would you like me to cover next? Your feedback is the fuel for future journeys. Thank you for joining, and see you again in other strange corners of space.